Here are a couple of double and half angle problems. Let's imagine cosine of u is 1/5 and we're in the fourth quadrant. So I always sort of start by trying to orient myself. Okay, so the x coordinate is 1/5. You can draw that as a 1/5 there with a hypotenuse of 1. Another way to draw that is you can say this is adjacent over hypotenuse, and so you have 1 and 5. Probably this is just slightly easier, but the methods are almost identical. We're going to use the Pythagorean theorem, 1 squared plus y squared equals 5 squared, so that's 25 minus 1, so y squared equals 24, so y equals minus the square root of 24. Now, 24 you can actually break into 4 times 6. So you can leave it as y equals negative the square root of 24, or you can write y equals the square root of 4, which is 2 root 6. I'll put minus 2 root 6 there. Okay. Same thing would happen here, except for you're dividing by 5. Okay, so what is sine of that angle? Right? This angle right here is u. Sine of that angle is opposite over hypotenuse. So negative 2 root 6 over 5. That kind of makes sense because we're in the fourth quadrant and sine should be negative. Well, but then what happens when we have sine of 2u? Sine of 2u, notice this is the fourth quadrant, so 2u is going to be something like there, and that much again. Well, remember that's 2 sine u cosine u. And so we've just got 2 times negative 2 root 6 over 5, right? Times 1/5. We'll put all that together. So it's negative 4 root 6 over 25. Should be pretty straightforward. For cosine, you've got a few options, right? Just for the fun of it, we might use 1 minus 2 sine squared u. You could use 2 cosine squared u minus 1 if you wanted to. We've got this right here, so we'll go ahead and calculate it out. 1 minus 2 root 6 over 5 squared. Let's see, so what is that? That's 1 minus 2 times 2 times 2, so that's 1 minus 8. Root 6 times root 6 is 6 over 25. What's that going to be? Let's see, that's 1 minus 48 25ths, and this is 25 25ths, so this is negative 23 25ths. And you could check using the other two equivalent identities that you'd get negative 23 25ths. What about this half angle? The half angle, you remember there's a plus or a minus, the square root of 1 for sine, it's minus cosine u. If it was cosine, it would just be plus cosine u over 2. Well, now I have to actually use my knowledge of the quadrant. So is sine of u over 2, if u is in the fourth quadrant, half that's in the second quadrant, and I happen to know that sine is positive. So I'm going to cross off the negative. So this is positive the square root of 1 minus 1/5 over 2. There's a number of ways to simplify. I usually just multiply by whatever the denominator is over itself, so 5/5. So that gives me, let's see, distribute that 5. 5 minus 1, right, the denominators cancel there, over 10, or we could say that's the square root of 4/10, or 2 over root 10, or, and I'm happy if you leave it there, but you could also reduce, right, 2 root 10 over 10, and then really root 10 over 5 is where it would reduce to. Okay, well, what about this problem? Fairly similar, except for we start with the tangent. For tangent, I almost always draw a picture that isn't on the unit circle. Let's see, I'm in the third quadrant, so opposite over adjacent is negative 6/5. Well, that's a typo to begin with because tangent can't be negative in this quadrant. Let's pretend like it was positive 6/5. So why is that? Because opposite has to be the 6th. Adjacent has to be the 5. If you're in the third quadrant, both of those are going to be negative, right? That's the picture you're going to have. Okay, so what is your hypotenuse? Well, negative 5 squared plus negative 6 squared equals 25 plus 36. So that's, let's see, 61. So h is going to be always positive, the square root of 61. So what's cosine there? Cosine is adjacent over hypotenuse, negative 5 over the square root of 61. What about cosine 2u? Well, since I have cosine, it seems really wise to use 2 cosine squared u minus 1. The other two require that I calculate sine, which wouldn't be that hard. I just don't have it currently. So what do I have here? 2, that squared, right? So that's 25 over 61 minus 1. What's that? That's 50 over 61 minus 61 over 61. So let's see, what do I end up with there? I guess that's negative 11/61. And here I have plus or minus the square root of, and I guess it would be wise to do them in order, plus or minus the square root of 1 plus cosine u over 2 and 1 minus cosine u over 2. But let's sort of keep in mind, if I'm in the third quadrant, where is this when I divide by 2? Well, if you take anything bigger than 180 degrees and divide it by 2, it's going to be bigger than 90. That means I'm going to be in the second quadrant. So in the second quadrant, what happens? Sine is positive, cosine is negative. So this is going to be negative the square root of 1, let's see, plus, I have cosine here, negative 5 over root 61 over 2. And then, remember, my approach is to multiply by root 61 over root 61. So what do I have? I have the square root of root 61 minus 5 over 2 root 61. And I would be, and of course that negative I made a big deal of keeping there is still there. Okay. I would be somewhat inclined to leave it in that form, although there are some other ways you could work to simplify. This is going to be positive, square root of 1 minus this right here, so plus 5 root 61 over 2 times root 61 over root 61. So what do we end up with there? Well, square root of root 61 plus 5 over 2 root 61.